So we're going to talk about adding rational expressions. These are going to be written as fractions, which is what a rational expression is. And the thing is, if you're going to add fractions, the rule is you have to have a common denominator. Regardless of how big your denominator is, it has to be exactly the same in order to add. So this is two fractions. These are two fractions. Their denominators are exactly the same. So basically at this point we just add the tops and keep the bottom. This one would become 2 on the top, x plus 2 on the bottom. The denominator does not change when you're adding. So we're going to take this understood concept, common denominators, add the tops, keep the bottom, and expand that into some bigger ideas. All right, the problem is going to come when your denominators don't match. And when they don't match, we have to force them to match. We have to manipulate this problem to make it match. And we've done common denominators since you were in elementary school. I think they start basic fractions in second or third or fourth grade. And so in order to do this, normally I ask my kids, what can both numbers become when we're talking about denominators? The problem here is that you have these terms that are stuck together with a plus sign, and I can't separate it. So what we're going to do is multiply them to each other. So I'm going to multiply this first. Where's my pen? There it is. I am going to multiply this first denominator by the second denominator. Then I am going to multiply the second denominator by the first denominator. So remember, whatever you do to the bottom of a fraction, in order to keep them equal, the value the same, we have to do the same thing to the top. So if I am multiplying the bottom by 2, I have to multiply the top by 2. If I'm multiplying the bottom by x plus 1, I have to multiply the top by x plus 1. So then I just multiply it. 2 times 2x is 4x. Now when I'm multiplying this by two things, I have to multiply it to both pieces. So 3x times x is 3x squared. 3x times 1 is 3x. And then my denominator, same thing, distribute that 2 in. Okay? At this point, if your denominators are not exactly the same, you have messed up. All right? So we have found our common denominator by multiplying the fractions by each other. Let me clean those lines up. That's stressing me out. And now when our bottoms match, when our denominators match, we simply add or subtract the numerators, which is the top, and we keep our denominator. So here's the thing. 4x plus 3x squared plus 3x. Normally, not normally, but what I need to do is I need to make sure there are no like terms. In this part, I have two x's, or two x terms. I have a 4x and a 3x, so I need to add those. When you get to this point, you need to see if you can add any like terms. When I add my x's, I have 7x, and then my 3x squared stays. Now this is the right answer. That's the right value. However, the way that textbooks and automated tests are going to want you to write the answer is with your highest exponent first. It's called descending order of variables. X squared, then no x. Just write it from the biggest exponent to the smallest, and then this is your answer. Okay, so find your common denominator by multiplying each other. And then any like terms, or subtract. We'll do a subtraction one next because there's one thing you have to watch for when you're subtracting. And simplify it down. That's it. So this is the same problem except it's a subtraction problem, and there's one thing you have to pay attention to when you are subtracting, and you have to distribute some things out. So we're gonna work through that. We're gonna kind of barrel through quickly the common denominator part. Remember, to add or subtract, you have to have a common denominator. To get there, we multiply them together, and whatever I do to the bottom, I do to the top. So what I end up with is 4x minus all of that. Now, when we get to this part, when we are subtracting, this negative has to be applied to all of these pieces. So what we're going to do is I'm going to talk about just the top for a second, because technically it's 4x minus all of this. So what you need to do is you need to put what you're subtracting in parentheses, because that minus has to attach itself to every piece, not just the first piece. So what's going to happen is this negative is going to go to this term, and it's going to go to this term. So technically what I'm going to have is 4x minus 3x squared minus 3x. If this was a negative, it would become a positive. So that negative out there, or that minus, has to change the sign of every piece in that next section of the problem. And at this point now I have like terms, 4x minus 3x. So my final answer is going to be negative 3x squared. Make sure you keep the sign. Plus, and you can write the 1x there because 4 minus 3 is 1. More often than not, you don't need to write it. And then your denominator is 2x plus 1. So I know I did that one kind of quickly, but the reason I wanted to do this one was to make sure you distribute that negative out. So let's do a couple more of these together. All right, let's work through this addition one. And of course, this one's slightly different because it has a whole number in there. And what is the rule? When you have one fraction, you have to have two fractions. So how do I create a fraction when I do not have one? How do I make 2 a fraction? You put it over 1. Okay, so I'm going to go ahead and write that as a fraction. That's one of our if steps from our very beginning working through fractions. If you have a whole number, excuse me, if you have a whole number, put it over 1. And now I'm going to find my common denominator by multiplying the fraction by the other one. So I'm going to multiply this whole set by 1. Whatever I do to the bottom, you do to the top. This one is going to be multiplied by 3x plus 2. So 1 isn't going to change anything on that first set. 2 times 3x is going to give me 6x. 2 times 2 is going to give me 4. And then down here, we're going to end up with 3x plus 2. So my fractions, let me erase these little lines. When I just gave away the answer by hitting the wrong button. When I multiply that out, I end up with x squared plus 6x plus 4. And then I add my like terms. Now here's the thing. When I look at this right here, I don't have any like terms. X squared and x are not like terms. So I am going to leave it just like this. Okay, so let's, sorry, I lost my train of thought. Let's review. If it's a whole number, put it over 1, multiply by the opposite denominators, and then if I have any like terms, I add, and you always keep your denominator. Nope. Yes, you keep your denominator. You add your numerator, which is your top, keep your bottom. Let's do a subtraction one. So let's talk about this one. If it's a subtraction, numbers are the same again, but the difference is it is a subtraction. So I want to review this negative distribution thing. If you have a whole number, put it over 1. All right, and then to find our common denominator, we multiply by the opposite denominator. Whatever I do to the bottom, I do to the top. Okay, so I end up with x squared, then 6x, where's my, oops. Well, come on, there it, nope. All right, 6x plus 4. Now it's minus all of this. So when I go to subtract that out, technically it's minus all of this, which means I just change the signs. That becomes from a understood plus 6 to a minus, plus 4 to minus 4. And because there's no like terms, then that is my final answer. All right, let's talk about when we have two complete different expressions on our denominators. The rules are not going to change. It's just going to get longer. We still need a common denominator. This, let me use a different color. This is still 1 unit because of the plus sign. This is still 1 unit because of that minus sign. So we're going to do the same thing. We're going to find a common denominator by multiplying by the opposite denominator. But remember, whatever I do to the top or the bottom, I must do to the top. Okay, so now I just distribute all of these things out. I am going to do 2 times x, 2 times negative 2, 3 times x, 3 times 3. I'm going to do the same thing down here. But the thing is, I only have to do this once because they're the same thing on the left and right. So when I distribute all of that out, I'm going to give you a chance to try it in a second at your own pace. I'm going to end up with 2x. Let me sort of delete these lines and walk you through as I do them. Two times x is 2x. 2 times negative 2 is negative 4. Plus 3 times x is 3x. 3 times 3 is 9. Now for my denominator, it's just x times x, and it's the same thing on this side. Then x times 3, same thing. Negative 2 times x, negative 2 times x, negative 2 times 3, negative 2 times 3. So your denominator is going to be the exact same. And that's what I end up when I distribute everything out. Now I need to add like terms. On the top, I have a 2x and a 3x. And then I also have a 4 and a 9. Whole numbers match, x's match. On the bottom, I don't have any whole numbers, I don't have any x squareds, but I do have x's. I'm going to add my like terms. So 2x plus 3x on the top, negative 4 plus 9 on the bottom. So 2x plus 3x is 5x, negative 4 plus 9 is 5. On the bottom, the x squared stays because there's no other x squareds. This negative 6 stays because there's no other whole numbers. Negative 2x plus 3x is x. This is my final answer. Now listen, your textbook and your homework problems are going to tell you to solve and to find any exclusions like we were doing on the last lesson where we have to set our denominator equal to 0. And I am not going to make you worry about finding any exclusions on this lesson because there's a lot here. So I should have said that earlier, but while I'm thinking about it on this slide, I want to say it now. On your homework, just solve these. So that would be the end of this problem. All right, I don't know why that says type equation here, except that my computer has gone berserko, so I'm going to have to handwrite this one. So we have 1 over x plus 1 minus 1 over x minus 1. Now, while these two things have the same exact numbers, the signs are not exactly the same. Therefore, it's not a common denominator. So what I am going to have to do is create a common denominator, and I am going to do that by multiplying by each other. And whatever I do to the bottom, I do to the top. So on the top, I have 1 times x, 1 times negative 1. That gives me 1x minus 1 minus 1 times x, 1 times 1. I'm going to work on just the top here because I'm having to handwrite this. As you can tell, I'm just going to run out of space. Now, remember, when you're subtracting, this minus has to go to all of the pieces. So technically, what I have is 1x minus 1 minus 1x minus 1. So all of that looks crazy. And I think that's why I couldn't type this one in because it looked like absolute values in there with all these ones. So what I have is I have 1x minus 1x. That goes away. Then negative 1 minus 1 gives me negative 2 on the top. Now let's talk about the bottom. What I'm going to do is I'll change colors. I'm going to work with this times this. X times x is x squared. X times 1 is 1x. Negative 1 times x is negative 1x. Negative 1 times 1 is negative 1. Now I have like terms, x minus x goes away. So on the bottom here, then what I have is x squared. Ooh. And that is the answer. I sort of hate all those ones, so I'm going to give you one to try and see how you do. All right, so let's look at this one. What I'm going to do is I'm going to give you a little bit of time to work it through yourself. So what I want you to do is I want you to get some paper out, pause this video, work this problem, and then come back and check your work. All right. Hopefully you've tried this one on your own. And are ready for me to check it. So the first thing we have to do is we have to find a common denominator. And to do that, we're going to multiply it by the opposite denominator. Whatever you do to the bottom, do the same thing to the top. Okay? So once you distribute all of that out, you should end up right here with x, or 1x, you can write the 1 if you need to, minus 4 minus 2x plus 4. And then remember, we have to distribute that negative out to both of those pieces after the minus sign. So minus, minus. That'll give you minus 2x minus 4. Now we add any like terms. Here's an x, here's an x, here's a whole number, here's a whole number. So you have x minus 2x, negative 4 minus 4. On the bottom, you have x's here that match. So your new simplified top is negative x, or negative 1x. 1x minus 2x is negative x. Minus 4 is negative 8. Then on the bottom, you have negative 4x plus 2x, which simplifies to that. So this is my answer. If you did not get that, take some time to look over. Let me clean some of these lines up. Take some time to look over this section here and see if you can figure out what you did right or wrong. And then I'll give you your homework assignment. For homework, I want you to do number 3 and 4 on lesson 82. So part of this is going to be a little bit of a review also from past concepts. Just a heads up. This is page 182. Oh gosh, you can hardly even read that. Page 182. And then I want you to do 3 and 4 from lesson 83. That is page 184. And then on lesson 84, just do number 3, which is on page 186. Let me know if you have any questions.